So for test 3, we have section 11.5, which is alternating series tests. So that, we did a problem earlier today. Be able to tell if something's convergent. By the way, the alternating series test only tells you if a series converges. It does not tell you if it diverges. If AST does not work, what do you have to do?
Test for divergence.
Test for divergence is then your buddy. So AST 11.6 is absolute convergence, conditional convergence, then the ratio test, and the root test. If you see a problem, and you will, if you see a problem about does this converge absolutely or conditionally or diverges, there are 3 ways, 3 techniques you could try to go for. So let me write to show absolute convergence. You would either use the definition of absolute convergence. I'll just call that A. Definition of absolute convergence. The ratio test, or the root test. Now, be careful about this, because although I'm saying this, it's not like you can pick your favorite one. The ratio test might not work. How would you know if the ratio test didn't work?
It's 1.
If the limit's 1. The root test might not work. How would you know if the root test doesn't work? If the ratio test didn't work, and if that limit's 1, and they kind of go hand in hand. If you try the ratio test and it does not work, don't try the root test. Go with the definition of absolute convergence. So you need to make sure you practice these problems and that you're comfortable with pulling out of your toolbox the one you need for whatever problem you're given. Yes. The root test wouldn't work when the limit is 1 of whatever the limit is you're taking for the root test. So we have that, and so you should be familiar, certainly, with those tests. Now, if the problem says, does the series converge, can I use the ratio test? Yes, because the ratio test, while it shows absolute convergence, if a series converges absolutely, well, it converges. Okay, so make sure you take a look at that. If you want some extra practice problems, you could try 11.7. I have not formally talked about 11.7, but these are just practice problems for the whole chapter. So I'll just write that's extra practice. And I would probably stay away from those at this point. But if you're looking for extra stuff, though. Okay, 11.8 is power series. That's power series introduction. 11.8, you're given a power series where you have a variable x in it. And so it's for what values of x does this series converge? So find the interval of convergence and the radius of convergence. So find those two things. For that, what do you use? Ratio test. Use the ratio test. You're going to get things like this. It might converge only at A, which A would be the number that it's centered around. It might converge on some interval around A, and so it would be the same distance on each side of A minus R, I think they use a capital R for that, A plus R, but I guess it wouldn't matter. What do you have to do at those endpoints? Test them. Test the endpoints separately. Test, if you get something like this, some interval, test the endpoints separately. The endpoints being x equals a minus r and x equals a plus r. And when you do that test, then you got to grab some of the stuff from earlier in the chapter, maybe alternating series or a p-series. Test them separately because that's where the ratio test fails. The ratio test fails at these endpoints. That's where the limit is 1. So here you plug in that value for x in the series and you try p-series or AST or something like that. Those are the two that I think of that are probably the most common at this point. It could be, when you look for the interval of convergence, that it converges for all numbers on the number line, even though it's centered around A. So if that's the case, you don't have any endpoints to check. So that's 11.8 rather. 11.9, more power series. So we're using this power series. N goes from 0 to infinity. When does this converge? Absolute value of x is less than 1. I called that the foundation. It is the basis of every problem. I think they worked in 11.9. 11.10, Taylor series. Taylor and Maclaurin. They're really, a Maclaurin series is a Taylor series. It's just what? A equals 0. So there's a formula for this. You need to be able to work problems with that formula, Taylor series and Maclaurin series. If I give you a problem, find the Taylor series, find the Maclaurin series, whatever we ask for. 11.11, which I briefly mentioned yesterday, this is Taylor polynomials. Taylor polynomials of degree n. That's not the title of it, but be able to find a Taylor polynomial of degree n. If you can find a Taylor series, you can find a Taylor polynomial. What do you do for Taylor polynomial? Is cut it off at degree n. It's just some of the terms of the Taylor series. And now, extra, be able to find determinants of a 2 by 2 matrix and a 3 by 3 matrix.